All right, Algebra kids, we're starting chapter 2, and yes, there is some more vocabulary to start off the chapter, but that's because we're going to be talking about a bunch of different kinds of numbers, as you can see, starting with whole numbers. So be patient, slow your video down, pause it when you need to, and get these written down because this will be a nice little reference sheet when you're doing daily quizzes and quizzes to follow along. Whole numbers, first of all, they start with 0. Starting at 0, 0 is considered a whole number, and then 1, 2, 3, 4, 5, 6, 7 to infinity. There are no fractions, no decimals, no negatives in a whole number. If you already know this, don't write it down. But no fractions, no decimals, no negatives. A whole number is just a number, usually the ones you count with, but starting with 0. The difference between that and integers is that integers could be negative. Negative 3, negative 2, negative 1, still 0. 0 is still an integer. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are integers to infinity. There are still no fractions and no decimals in integers. The most common mistake that students make is when they see a negative, they automatically think that it's an integer. And they'll say, oh, that's an integer, but it's not an integer because it cannot have a decimal, it cannot have a fraction. Those are not integers. So if you maybe want to make a note, what are integers? Integers are any whole number and their opposites. Any whole number and their opposites, meaning if 2, then so is negative 2. 7, negative 7. Basically then, a number like 2, 7, 15, 22 can be classified as an integer and a whole number. It is both. Any positive whole number would be labeled an integer and a whole number to describe it. Other vocab, rational numbers. So what do we call them if they're not whole numbers? They are rational numbers. Any number that can be represented as a fraction is a rational number. So if it can be 2/3, if it can be 1/8, if it can be 7 and 7/15, and it can also be negative. So negative 2/3, negative 1/4. They can be whole. They can be integers. And repeating and terminating decimals. Doesn't matter which one is which. If it's 2.5, it's still a rational number. If it's 2.333333333 continuing, it's still a rational number because we can turn that into a fraction. Whole numbers are also rational numbers. So now you got the number like 7, and you say a 7 is a whole number. It's also an integer, and it's a rational number. You've got all 3 of those things are true about that. So if all those kind of decimals are rational numbers, then what are irrational numbers? Irrational numbers is any number that cannot be represented as a fraction. And there's not many of those. Most of the ones that we work with can be, but pi, and I just pointed up there because I have pi up around my entire room as a border, if you've never been in my room. It goes all the way around through to every wall, every ceiling. Pi is irrational. So is any square root that you take that doesn't come out to a whole number. If you type in the square root of 2 on your calculator, the square root of 5, the square root of 7, your calculator will keep going and going and going and going and going. It has to stop after 8, but it is irrational. And then finishing up, we have real numbers, all numbers that are possibly on a number line. Any and all numbers that are on a number line are real numbers. So I don't care if it's irrational, rational, an integer, a whole number, any and all of those are real numbers. So you might ask, like, well, what's not a real number then? We don't know real numbers that aren't real. We haven't learned them yet. You're not going to know them yet. You're going to get all the way through algebra and geometry before you learn about not real numbers, which happen in Algebra 2. If you're curious and you just want to see, try taking the square root of any negative number. If you tried taking the square root of a negative 100, you would think the square root of 100 is 10, but the square root of negative 100 is not negative 10. It's not real. Your calculator will tell you that there's an error. So we'll get into those in Algebra 2. Another definition for opposites. A lot of times I will use the word opposite instead of calling it a negative. A positive 4 and a negative 4 are opposite to each other, but maybe we'll call it 4 and the opposite of 4. Why would we do that? Because what if we don't know what x is? If you don't know what x is, then you'd have to say the opposite of x. You can't say negative x because we don't know if it's negative or not. Here's a good example of that. It says if x equals negative 2. If x already is negative 2, and you've been told that x is negative 2, and then they tell you that they want the opposite of x, I'm going to cover that up with my forehead. If they want the opposite of x, well, if x itself is negative 2, what's the opposite of x? The opposite of a negative 2 is a positive 2. We don't say negative, negative 2. So if we were back into the translating mode like we were in chapter 1, we would have to translate this in words as the opposite of a negative 2. So that's why we refer to it as opposites. So hopefully you've paused this enough to get all that written down. This you don't have to draw and color and make boxes and all that, but let's get a relatively simple flow chart going here. Everything that we know of is going to be real numbers. They're all real numbers going all the way through. So, oh, there, I don't have a shadow on my face. Maybe if I were taller. All real numbers. They're either rational or irrational. Either they have a decimal point that terminates or repeats, or they have a decimal point that just keeps going and going and going and going. And if you want to put an example, pi is an example. Square root of 2, square root of 7, square root of anything that's not a whole number. Integers can be negative, but they still have to be whole numbers. And they're opposites in whole numbers. So what you're going to use this chart for is basically if I give you a number, I'll give you my favorite number is 12. I always use it, and it was my basketball jersey number. Number 12 is a whole number. But because number 12 is a whole number, you can't just say that it's a whole number. You have to say it's whole, it's an integer, it's rational, and it's real. So when asked about a number, you have to describe it with everything that's above it on this chart. It is all of the above. If you picked a number that was an integer, okay, if you pick a number that's an integer like negative 8, you would say negative 8 is an integer that's rational and real. If you picked a rational number like 0.7, you would say it's rational and it's real. They're all going to be real. If you chose an irrational number, that's all you can say is that it's irrational and real. Take a second to draw this chart. It's, well, maybe a minute. 5 rows down, no, 5 rows across and 6 rows down. 5 rows across, 6 rows down. Pause it, draw it, and come back. All right, you should have it all drawn. Now what I want you to do is put an X in every word up there that describes these numbers. Now notice I didn't put real up there. The reason why I don't have real over here is because then everything would just have an X in it. If you think negative 2 2/3 is a whole number, put an X in that. If you don't think it's a whole number, leave it blank. Go ahead and fill that out. Come back as soon as you're done with it filled out. Make sure you pause it. And this is what it should look like. If something is a whole number, it's everything except irrational. Because notice irrational is not on that same side of the chart as a whole number is. If something is a decimal, it's not whole, it's not an integer, it's rational if the decimal terminates, which it did. If something is a negative, doesn't automatically mean it's an integer. Erase your X if you put that in the wrong spot. This is a negative decimal. It is a decimal that turns into, or a fraction that turns into a decimal. A negative fraction is just rational. You cannot put integer in that just because there's a negative. In this one, you can put an integer because it's a whole number that's negative. And if it's an integer, it's also rational. Then go ahead with the square root of 8. If you look at the square root of 8 on a calculator, it is 2.828427125, and you know that nothing has repeated on it and nothing has terminated other than it ran on a room on the calculator. So that makes it irrational. That's what your chart should look like. The only one that's irrational was the square root of 8. And again, if we were going with real, we would put another column, but they are all real. I think I ran out of X's. They all would be real, even that one. Okay, if you haven't used it before, if you haven't found it yet, you got to find the square root button on your calculator. The square root button on your calculator is right here. It's with the x squared, it's next to the 7, but notice it's in blue above, like smaller than the x squared button. And because it's in blue, you have to go up here and hit second before you hit square root. And it makes sense that a square root button is on a square calculator because they do the exact opposites of each other. If you square root 100, you get 10. If you square 100, or square 10, you get 100. They're exact opposite functions of each other. We call them inverse functions, technically. So you're going to find that button on your calculator, and when you use it, you're going to use it to evaluate these expressions. Go ahead and put those in your notes. And then I'm going to show you what happens if you have a calculator like mine, only maybe not pink. That's just cool that it's pink. When you type in the square root button, it puts a parenthesis on there. Okay, if you see that parenthesis, I'm trying not to give you a glare. If you see that parenthesis, it keeps showing my lights. You have to finish that parenthesis for it to work properly. Now, you might recognize, no, mine works anyway. It does for now, but soon you'll find out when it doesn't work. So it's a good habit to get into, to just finish that parenthesis. Square root of 400 is 20. Negative square root of 16. Remember, your negative is down here. Negative. Then go ahead and hit your square root button. Oops, I didn't get a negative in there. Negative square root of 16. Finish with a parenthesis, because we're going to need it later. So again, it's a great habit. And you get negative 4. Because this is the opposite of the square root of 16. The square root of 16 is 4. We need the opposite of it. How are they coming up with this number if you don't know your square roots? It's 20 times 20. How do I get 16? 4 times 4. How do I get 81? 9 times 9 is 81, which means the square root of 81 is 9. This may be a foreign symbol to you. Okay, sometimes when it's printed out, it looks like this line is like connected. It's not really, it shouldn't be. It should be a plus sign and a minus sign. You're going to need that in geometry and algebra 2 also, so we're practicing it now. The answer to this could be a positive or a negative 9, and it makes more sense to put a plus or minus like that than it does to write it like this. That doesn't look the same. So if they give you a plus or minus in the problem, you must put a plus or minus in the answer, or they're going to mark it wrong. Go ahead and try these 3 on your own. Write them down, pause the video, and come back to it when you're ready. Okay, you're back. You should have gotten negative 17 because it wants the opposite of square root of 289. This one got you plus or minus 21. And what happened when you tried to put the square root of a negative 100, even if you close your parentheses, if you tried that, domain error. Do not write domain error on your answer. What you're going to write here is not real. We talked about this all the way up here in the instructions. We didn't say no solution. We didn't say, can't do it, no way, not going to work, error. If you get something that's not real, I want you to actually write it as not real. That's how you answer that question. All right. Not all square roots are going to have perfect whole numbers as answers and integers. So when it says approximate square root 52 to the nearest integer, integer means that it's going to be a whole number, no decimals. It could be negative, it could be positive, depending on the problem. So you're going to take your calculator, clear out that negative, go ahead with second square root of 52, close it, and when you hit equals, yeah, it's going to give you an irrational decimal because it's not going to stop. The nearest integer, you're going to look at that 2 and say that 2 is not bigger than 5, 5 or bigger, so I'm not going to round up the 7. I'm going to just keep it at 7. So approximately 7 is your answer. And maybe you could know that in your head without a calculator. If you know that 7 times 7 is 49, and 8 times 8 is 64, it's definitely 52 is way closer to 49 than it is to 64. So maybe you could do that without a calculator. But you're always going to have this. I'm never taking it away. And as you go ahead with these, you take the square root of 75, and you get 8.66. Keeps going, 0, 2, 5, 4, 0, 3, 8. 6 is higher than 5, so that rounds up to 9. Square root of 240. Take a look at the square root of 240. Most people don't have a problem with the square root. They have a problem with the rounding on this problem. I've seen people say, all right, I got to decide, is that 15 or is it 16? And they go back here, take the 9, say that 9 is bigger than 5, so they turn it into or turn that 4 into a 5. Then they take that 5 and turn that into a 6. And their answer is 16. That is illegal math. You don't get to go back here and try to round. If you are rounding, you only get to look at one number at a time, and it's the immediate first number. So if that says 15.4 and it asks you to round to the nearest integer, your answer is 15. Ignore anything past the 4. All right, and on this one, don't forget the negative. What's the opposite of the square root of 20? And if you type in 20, you get 4.47. Here's another one of those. 4.47, ignore this 7. It just is going to round to negative 4. You don't get to round up and round up again. Okay, and finally, it's going to ask you to put these numbers in order from least to greatest, then label them with the proper description. This is our last problem. Label them with a proper description. You have to first convert them all into decimals. Otherwise, you don't know how big they are. And then when you write them, I'll show you, we'll write it in order. So convert 1 over 6 to a decimal. Take 1 divided by 6. It's about 0.166 repeating. I'll put a 7 there. We don't use repeater bars in high school. The square root of 12, but you need it to be negative, is about negative 3.46. We already know this one is 1.75. We know where 0 is, and this is 0.6 repeating again, but it's negative 0.6, or I lost my decimal, 0.66666. But instead of a repeater bar, just round it at some point. So the very smallest one is negative 3.46. It's the furthest left on here. But I don't get to write negative 3.46 down. You have to write square root of 12. Go back to the original problem. So that one's done. And then, of course, the next negative is negative 0.6667. Don't write that. Write negative 2/3. 0 will come between positive and negative numbers. Which one is smaller, 1/6 or 1.75? Definitely the 1/6, and then the 1.75. Least to greatest, then label them with the proper description. I'll let you shortcut this. If you look at the square root of 12 on your calculator, negative, you get negative 3, oh, I already knew this, negative 3.46, it's going to keep going. That is irrational, and IR is fine for irrational. But if you do negative 2/3, you get negative 666666666, which is repeating. So that one is rational. Ready? Maybe? 0 is a whole number. It's on our list. It's also an integer. It's also rational because we could make it a fraction. And it's real. Actually, all these are real, so we're not putting real on all of them. If you look back at this, a whole number is an integer is rational. We do not have to write real every single time because in Algebra 1 we only talk about real numbers. Finish up with the last two. 1/6 is a decimal fraction just like 2/3 is, and it's rational. Notice I didn't put integer on here. You don't put integer for negative 2/3 just because it's negative. Integers have to be whole. And here is one more rational at 1.75. If it repeats, it's rational. If it terminates, it's rational. If it doesn't do either one, it's irrational. And 0 can be whole, integer, and rational. All right, that's it for your chapter 2.1 notes. Hopefully you got them all written down in a notebook this time. Some of you didn't do so well on that on chapter 1. Go ahead to the book assignment and get started with those. Thank you.